All right, friends, welcome back. I hope you had some coffee and you're ready for this next block. I have with me already on the stage Andrija Petrovic, Senior Machine Learning Architect at Intellya, who will have a presentation today entitled A Hybrid LLM-Based Enterprise Chatbot Solution, Weaver Peer by Intellya. Andrija, the stage is yours.
Okay, thank you. Can you hear me now? Yeah, everything is fine. Okay, first of all, yeah, I'm going to introduce myself again. So, my name is Andrija, and I'm machine learning engineer at Intellya company. So, and I'm going to present you this hybrid LLM-based enterprise chatbots solution that we developed in Intellya. So first of all, there is going to present you some general agenda about this presentation. So first of all, I'm going to present you an AI-driven ecosystem that we implemented in Intellya. After that, I'm going to introduce Weaver, then of course retrieval augmented generation, Weaver peer, and references regarding our implementation of Weaver peer. So, as you can see, Intellya is very huge. It's not a huge company, but it has 3 different frameworks and two different products. We have first product that we developed is customer development platform, and this platform is called Selecta. So, and another product that we are going to speak about now is Weaver and Weaver Peer. Weaver is AI-driven assistant or robo-advisor for clients, and Weaver Peer is knowledge-based AI system solution. So, regarding this, at our core, there is AI core team or AI team that is dealing with implementing a wide variety of different algorithms that are part of Selecta platform and that are part of Weaver and Weaver Peer platform. So, inside of this AI core, we have developed a wide variety of different machine learning algorithms. Difference, it's very important to emphasize difference between these two, because after that I'm going to show you general architecture of Weaver Peer and Weaver. So Weaver is a personal AI assistant. It is a chatbot that is using NLU engine, so natural language understanding, really simplified and well-known approach that is using story or scenarios, intent and scenarios in order to answer the questions regarding to client needs. And on the other hand, there is Weaver Peer. It's knowledge-based AI solution that is incorporating retrieval augmented generation on one hand and large language models on the other hand. So we are combining both of them. And Weaver Peer final version is combining Weaver and Weaver Peer. Okay, just a second. Okay, if you take a look at our client's improvement and what we are basically doing, you can see that our products are gathering data from different kind of sources. So there can be core system, mobile application, wide variety of internet banking sources and similar stuffs. We are feeding this data in our algorithms, and we implemented several different algorithms. We have implemented also optimal control models that are based on contextual bandit or reinforcement learning, segmentation models, NLP models, wide variety of different statistical models and similar. And all of these stuffs are part of our products, Selecta and Weaver Peer. If you take a look at this slide here, you can notice several different things. So basically, as I told you, Weaver is based on the intent and scenarios framework. So inside of Weaver, we can implement a wide variety of predictive statistical and NLP models that are inside of the story. So for example, if you have a story that is based on, for example, recommending some particular product to client or customer, in that particular case, we can inside of that story or inside of that scenario implement the algorithm that is based on recommended products based on customer history and different data that we are gathering from different sources. On the other hand, there is AI core solution, and it is Weaver Peer. So, and it is solution that is capable to gather or answer the questions of that customer ask based on some company's documentation that is already uploaded inside of the peer framework. It is very important to emphasize one thing, is that as you know, Weaver is, or this intent-based scenario chatbot is much more reliable compared to the Weaver peer. However, you need to make wide variety of scenarios in order to answer different kinds of questions, and that's the problem. And because of that, we tried to connect these two solutions in one solution, and it's Weaver peer final version. Okay, related to Weaver, I will be very quick here regarding this part. So as I told you, it's based on intent and scenario chatbot, and as you can see here, the main idea of Weaver peer is to first reduce live agent reliance, then to provide, okay, so basically we don't need live agent because Weaver is capable to handle most of the requests in everyday needs. Then there's cross-channel communication, so it's possible to provide customer multi-channel support if it is needed. Then of course we have advanced administrative tool. It means that Weaver is, so the clients who are using Weavers is not able to know any kind of code. We already have implemented everything, so scenarios are relatively easily to input inside of the Weaver and to use it. There is also Weaver as robot advisor, so Weaver is capable to, or is having a wide variety of knowledge regarding financial data, and it can be based on domain algorithms or the algorithms that are developed by using some machine learning techniques. Okay, and here are some basic covers regarding Weaver, or some examples that are related to Weaver. So as you can see here, we can ask Weaver about, for example, give me what documentation I need in order to open the bank account. Is there a branch near Boulevard Zoran Đinđić? So Weaver is connected with different APIs and different other services. It's pretty modular. Okay, Weaver is also capable to provide small talks. It's of course a good thing regarding that it's improving customer experience, because Weaver is very friendly, user-friendly chatbot. And as you can see here, Weaver can provide not only answers, or Weaver also provides multilingual support, which means that Weaver can be used on different languages. Okay, here is an example how the Weaver is used in Serbian language, for example. So, okay, another thing that is really important is that, just a second, these are all scenarios, I'm going to skip some of them. Weaver can also be used as healthcare checker, and here you can see an example where Weaver is used as in order to appoint or schedule the meeting with some doctor. So there are domain-based algorithms that are recommending a doctor based on patient needs, some particular doctor, and it's pretty straightforward to schedule a meeting with Weaver. Weaver also supports speech-to-text and text-to-speech support, so everything regarding it, of course. And now let's go to talk a little bit more technical about this RAG and retrieval augmented generation. So until now I just presented you a simplified chatbot that is using just intent and scenario, so it's storytelling support. And now take a look at this RAG. I suppose you already heard a lot about it on previous presentations, but I just want to emphasize, as you already know, today people are using large language model. However, it's very important to emphasize that we are not aware how large language model are memorizing things. So they are putting all the things in internal knowledge. And if we want to add some additional knowledge to large language model, we can add it by fine-tuning the model. So one procedure is by fine-tuning the model. However, the results that we obtain after fine-tuning model are often not so reliable, so we are not going to be, or the model sometimes is not aware or not completely aware about the knowledge that we provided to the bot. There are also problems regarding catastrophic forgetting and losing the memory on which the model is pre-trained and so on. So nowadays, the biggest thing, or nowadays the biggest intention of the scientist and researcher is aimed at splitting the knowledge or splitting LLM support and external knowledge. So the goal is, of course, to split knowledge, to use some external knowledge, and to use LLM as a reasoning or to use LLM as a tool that is going to answer questions, but to extract knowledge from some other on other place. And because of that, we implemented RAG. And as you can see, I suppose you are familiar with RAG. So here we have some query or question that is related to documents, and we want to find the answer in the documents. And if you can take a look at this particular image here. So first of all, okay, it's going to be repeated again, but this slide again. So anyway, what is happening here? Query is encoding in some latent dimension. Inside of that latent dimension, we are trying to find documents that are close to our query based on different similarity measures. What kind of similarity measures we can use? We can use any kind of similarity measures that are available. After extracting or retrieving top N documents that are related to our documents, then we are going to use some summarization, sequence to sequence, autoregressive, or any kind of other model that is going to summarize the context and the query in one logical expression that is user-friendly and completely suitable for customers or clients that are asking questions. So this Weaver Peer version number 1 is something that we developed. It's pretty straightforward thing. It consists of 3 different components. The first component is vector storage. The second component is, of course, embedder, or in this particular case, it's encoder model. And the third one is large language model. Okay, I'm going to speak about each of these components. First, vector storage. Of course, we used a wide variety of different vector storage database. We started implementing Weaver Peer, I think it was December last year. So before retrieval augmented generation was popular. Now it's extremely popular, and we started with Elasticsearch as vector database. Today we are using also Chroma or Milvus, any other vector database that is suitable. Okay, latency is a little bit, it's small differences between the latency regarding retrieving documents based on the query. If you take a look, this was our general architecture. This is Weaver V1 architecture. So when first client is uploading the documents are uploaded, and if they are scanned, we are using OCR or any other procedure that is capable to convert image into the text. After uploading the documents, we are using batch processing, and batch processing is a part that is related to feeding the documents inside of the vector database. As an encoder model, there are 2 possibilities that, or this is embedder model, there are 2 possibilities that we are using right now. It's OpenAI embeddings and it's trained model, our own trained model artifacts. During the inference procedure, of course, we are using client ID and question, retrieving the model that is specific for some particular client. And after that, we are embedding the question and finding the most similar, retrieving top N paragraphs that are related to that question based on some similarity measure. After retrieving that paragraphs, we are then the questions are going, or the context of N paragraphs with the question is feeded into the prompt, and after that used as an input to OpenAI or GPT or some other large language model, and then answers are returned to final customer. Okay. Okay. So regarding embedder, this is a really important thing. So first of all, during the December last year, we were unavailable to use OpenAI embeddings because text ADA models were not yet. They were not, API regarding this model was not available, and then we developed our own models. So there are 2 possibilities to use. First possibility is to use OpenAI embeddings or text ADA as embedder or encoder model, and other possibilities to use our own developed model. So this is on-prem model that is specifically pre-trained on some specific language. We pre-trained these models to wide variety of different languages like Russian, Vietnamese, Arabic language, and similar stuff. And so basically our implementation regarding embedder can be completely on-prem. If we compare different benefits and advantages of on-prem implementation and OpenAI embeddings that we are obtaining by calling API, there are different benefits and of course or advantages and disadvantages related to first implementation and second one. In the case of OpenAI embedders, benefits are related that it's relatively cheap to implement it because we don't need additional infrastructure like GPU and similar stuff. However, the problem is regarding ongoing costs and relatively poor results. I'm going to provide you comparison how the OpenAI embeddings are comparing with our own fine-tuned or pre-trained model. First pre-trained, then fine-tuned model. In the case of pre-trained sentence transformer models, we tried a wide variety. Once I'm only talking about SOTA models. So benefits is that we are eliminating ongoing costs, of course, and we are offering much better performance regarding it. Of course, consideration or disadvantages are regarding to infrastructure costs that is pretty high in this particular case. And here are the results. I just presented you results regarding different models. So as you can see, these Arabic, Vietnamese, English, and Serbian are sentence transformer that are first pre-trained and after fine-tuned on our language. And these OpenAI are the models that are used as embedders as text ADA model. And what you can see here is that we can achieve around 20 to 30% better results compared to mean average precision, mean reciprocal rank, and of course accuracy cosine is not, we couldn't compare using this metric. So yeah, and because of that it's much better to use our own on-prem model. What is another advantage is that for each customer we are fine-tuning model on customer documents. So the model that is, okay, first pre-trained, that's our model, then we are fine-tuning on customer documents, so the model can be used just on customer things. Another thing is that we have implemented automatic solution for generating question or creating a training set based on customer documents, so we can create our own data set based on customer documents by using, of course, large language model in order to fine-tune the model and for some specific purpose. And at the end, this is not the end, of course, but I just want to mention that completely the same thing we are doing with large language model, we can use OpenAI embedding model. And in the case of using OpenAI models, okay, it's pretty straightforward. It's context summarization. We are just sending top 10 paragraphs with context and we are retrieving results regarding it. In this particular case, in the case of OpenAI, there are benefits regarding low infrastructure cost but high ongoing cost. And the problem with OpenAI is that there are a lot of clients who have problem with privacy issues regarding data, so they cannot send their data on, they cannot use OpenAI in this particular case. So how we are solving it, we are trying, or we are using open source models like Llama V2, Mistral, Zephyr, and so on. And this is some ongoing work that we are working right now. I have first results regarding it. So basically, because Llama V2, Mistral, and similar models are not supporting multilingual languages, we fine-tuned the model or pre-trained model on our own data set. We created the data set that for special purpose and used a wide variety of different approaches. Now I'm not going to discuss about the pipeline that we are using but as you can see, we are using parameter efficient fine-tuning, LoRa library. The models are trained on 2A100 GPUs. And even though we are still not very satisfied with the obtained results, as you can see, this is something that we obtain as an answer. For example, what is the temperature outside now? And as you can see, if you understand Serbian language, you can see that there are some misspelling issues and similar stuff. However, we just started training the model, and these are the first results. So I suppose that in the next couple of weeks, we are going to have much better results compared to this one that I'm presenting you right now. Okay, now after implementing this, we are now using ViverPeer version 2. ViverPeer version 2 is a little bit different compared to the ViverPeer version 1 because clients usually have a lot of data that are stored in structured database like SQL, and as you can see here, what we are doing, we are trying to create a new RAG that is capable not only to answer questions from vector database, but also to answer questions from the SQL database. So at the beginning, we have large language model who are deciding should the model go directly to vector database or should the model generate the query. After that, if the model generates the query, then we are going to obtain some answer by applying that query on SQL database. And then the model can decide should the model go to get additional data from vector database or directly answer the questions that are regarding model architecture. Yeah, this is the second version of ViverPeer version 2. So in this particular case, we are capable not only to retrieve vector information from vector database, which are unstructured and independent, but also to retrieve answers from SQL database, which is very important right now. Okay, and of course now as I told you, we were trying to connect these two. So first Viver and another ViverPeer or this RAG version 2. And of course, why we are doing that? Because of course Viver or chatbot that is based on scenarios or on storytelling is much more reliable compared to the one that is based on using RAG or large language model and similar stuff. And what we are trying to, what we did here, okay, this is not the best slide, this is the one that is much better. So what we did here, we are now implemented the whole thing that I previously showed here with Viver. So when customer asks some question, first question is going to go in NLU engine. NLU engine is text classifier that is going to decide is it better to go on Viver scenario or are there any answers inside of the Viver scenarios or is it better to go directly on RAG, okay? If Viver doesn't have any answer to customer query or client's query, and if this part that is regarding to ViverPeer version 2 also doesn't have any question, or also doesn't have any answer to customer query, what we are doing then the LLM is going to use internal knowledge to answer the question, okay? And what is important here, every time when we ask a question, okay, the question is going to NLU engine. If the answer is going to be provided from this RAG part, then that answer along with the question is going to go in conversational buffer. Conversational buffer is going to stack these messages, okay? When the customer asks new query, okay, then conversational buffer is going to take that query, go to LLM. LLM is, or large language model is going to summarize a query in one simple sentence that is again going to go in NLU engine. So every time the customer asks new query, we can follow the story and we can decide should we go on storytelling scenario or Viver, or should we go in this RAG or retrieval augmented generation architecture. And that's the main idea. Okay, at the end I'm just going to present you several use cases where we implemented Viver. So as you know, there are a lot of our customers that we are that are part of it. You know about REA, I suppose. It's Raiffeisen Advisor. Then there is this chatbot Rashid from Duhan Bank. Again, it's one of the implementation of Rashid. Rashid is also implemented with a variety of machine learning algorithms. There is Mina, it's for public sector, chatbot for public sector. Of course, and there are a lot of different customers that that are using our servicings regarding Selecta and chatbot. Thank you for your attention. If you have any question, feel free to ask me.
Thank you very much, Andrija. Do we have any questions? Yes, please.
Thank you very much. So I have, in fact, two questions. So first is when some of your clients select some of the open source models like Mistral or Llama 2, how you cope with licensing? Because can you embed it and not making it overall open source? And another thing is now you're going really deep into the topic and looking at the commodity of AI, everyone is promising the similar functionality. What are the usual traps that you see that people consider as easy, but they are not in order to make a system like this?
Yeah, okay. First of all, regarding the first question, we are using Mistral and Zephyr, so they are completely open source, but weights on which we are training the model are not going to be publicly available because that are our weights. So the parameters of model we don't need to share with nobody. So regarding licensing, I think it's not a big problem in that particular case. Second question is more interesting regarding it. So basically, regarding retrieval augmented generation, the main problem here regarding vector database and similar stuff is that documents are not connected with each other. So when you chunk the documents or when you split the documents in chunk, vector database is going to look at each chunk completely independent from another, okay? And that's the biggest problem regarding retrieval augmented generation. We were trying, and we are still trying it, it's not our scope, to use, for example, knowledge database to solve this problem, okay? Or graph database. In case of the graph database, we were trying to extract entity and object, to connect entity and object with each other, and then the whole story, how the documents, the story regarding documents is going to be dependent on each other. What I mean in that particular case, if you have something in the first chunk of document and something that is also related to it in some other chunk of documents, it doesn't mean that RAG is going to retrieve both of them and that it's going to connect it. So because of that's the biggest problem with RAG nowadays. And I suppose that in some near future, we are going to figure out how to some distribution of text, or this part, when we take a look at the whole document, it's one predefined distribution of words, how not to make it completely independent from each other. And I think it's the biggest problem also in the case of implementation. People are expecting that they are always going to obtain an answer like they are obtaining answer when they are using large language model. No, it's not possible, because large language model, okay, it cannot reason, but it can connect different knowledge from different parts of documentation. In the case of RAG, we are not capable to do so. Yeah.
Sorry, a follow-up. So just what you said is, I believe, important to having that glue, semantic glue, and having some type of ontology of knowledge graph. Seems to me that we are all now too focused on LLMs, and we are disregarding a couple of decades of science that goes into that knowledge graph part.
Absolutely.
So what is your impression?
Yeah, absolutely. Knowledge graph, I think, is something that is going to help to improve this external knowledge and extracting external knowledge in a right way. Yeah.
Thank you.
Okay, thank you.
Any more questions? Yes, please.
Thank you for the presentation, and congratulations on the work that you're doing, because you're serving Serbian clients as well. So, you know, not many people here are doing this. And we'll definitely try to, I'll try to schedule a separate meeting with you to talk more on this, but I would like to ask you a quick question on actually the resources and data sets that would help you in fine-tuning or continuous pre-training of Mistral or Zephyr. What are you missing from the public domain? Is it like a huge pre-training corpora? Is it fine-tuning data sets?
Yeah.
If we had that, what would help you?
Yeah, basically, regarding this, of course, it's going to help us to have 10 A100 GPUs device. Infrastructure is the biggest obstacle nowadays, but regarding not only infrastructure, we are making our own data sets. Unfortunately, how we are making, I'm going to tell you, it's not something that is that I should hide. So we are making data sets by using, for example, Orca data set and then translating it in Serbian language. That's the only way that we can do that. Yeah. So data sets is something that we are struggling with, and of course, infrastructure is the second thing. Yeah.
All right, any more questions? Great. Andrija, I have two things for you. First of all, a certificate of appreciation.
Oh, thank you. Thank you.
And secondly, Mr. Nebiosha, the next speaker, would love to speak to you after his session.
Okay.
So thank you very much. Thank you.